And finally, welcome to Calculus and Vectors exam review for Unit 8, Lines and Planes. This is our second unit on vectors in general and using vectors to represent lines and planes. In particular, when we get to three space, it becomes interesting and we can start to expand our understanding of linear systems and systems of other things. So we've just got two examples here. We don't have a system of three planes to review, but we got a couple other kinds of systems to quickly review. We've just done this, so hopefully it's very fresh for you. And the instructions say, as always, for each system, give a geometric interpretation, state the number of solutions, and solve the system where possible. Now, one of the main things, and I've said this all along, is, my goodness, when you are looking at this, you had better identify very quickly what it is you're looking at. So if you can't tell right off the bat that these are two lines and this is a system of two lines, then you really got to go back to the drawing board and figure this out. My question for you is, what would it look like if it was a plane in vector notation? How do you tell the difference between a line in vector notation and a plane in vector notation? Well, a plane in vector notation would have plus s and plus t, because a plane requires two direction vectors. So it would be very obvious, I think. Well, I know it would be. This is just one direction vector. This has just one direction vector, so these are both lines. When I take a look at example 2, we're just going to look at it to compare. I've got one line, because again, this only has one direction vector. And I've got a plane because there is no scalar representation of a line in 3 space. This is in 3 space because it's x, y, z. So it is absolutely a plane, and you should know that, and you should know that well and quickly. So let's start with this first one. And first of all, what do we always want to start with when we're looking at two lines? You had better start with comparing the direction vectors to make sure that they are not parallel. This will save you a ton of time if they are parallel, and so it's a worthwhile test to do. So if the direction vector, the first direction vector is just 6, 4, -2. Now if you wanted, you could divide each of those by 2 because they all divide, and you'd get 3, 2, 1. But you don't have to. That's kind of up to you, obviously. And this one is 1, 2, -3. So they are not scalar multiples of each other. And we say that d1 not equal to kd2. Now, if it is equal to kd2, you should say what k is. Don't just say d1 equal to kd2. Say d1 equal to 2d2. Okay, give that number. But they are not equal, so they are not parallel. So we probably should have opened with this, but what are the possibilities of two lines in 3 space? There's 4 possibilities. 2 of them are parallel, 2 of them are not parallel. So we've already cut it in half with just with just a brief observation of the 2 direction vectors. We've narrowed it down from 4 to 2 possibilities. The 2 that are parallel is either parallel and coincident or parallel and distinct, and you would check that by taking a point on one of them and checking on the other. But if they're not parallel, then what we have to do is consider the parametric form and solve a system. So for x, I'm going to say 5 plus 6s. So 5 plus 6s equals 2 plus 1t, or 2 plus t. So I'm setting the x parametric equation in each of the lines to each other, and then I'm going to set the y parametric equations to each other. So this is -4 plus 4s equals -3 plus 2t, and the z. And this is 1 minus 2s equals 4 minus 3t. Okay? And so we have equation 1, 2, and 3. And we're going to pick our favorite 2 that we can eliminate, either s or t, and then we'll take that and solve the system of just 2 of these And then whatever our solution is, we're going to check it in the final one. Okay? So I think I am going to take equations 1 and 2 because this is 2t and this is 2. So I'm going to go 2 times equation 1, which gives me 10 plus 12s equals 4 plus 2t. And I guess I'll go negative 1. I should have multiplied that by a negative as well, but I'll go negative 1 times 2. So that's 4 minus 4s equals 3 minus 2t. That's easy enough. And so then I'm going to add these together. So this is 14 plus 8s equals 7 plus 0. Moving the 14 over, I get 8s equals negative 7. And s is negative 7 over 8. Okay, call that equation 4. And I'm going to take 4, and I cannot sub 4 into 3. Now, this is what some people did on the test, and that's not going to work. It's a big mistake. I have to sub into one of the original 2 equations that I started with. So I will sub it in to equation 1. And I get 5 plus 6 times negative 7 over 8 equals 2 plus t. And you might just want to punch this straight into your calculator, which is what I'm going to do. So 5 plus 6 times negative 7 over 8. And then I'm going to subtract 2, so I'm going to do all this in one shot. And I get, so I'm moving the negative 2 over and subtracting, and I get negative 9 over 4 equals t. Okay, and then what do I do is I check s equal negative 7 over 8 and t equal negative 9 over 4 in equation 3. So I leave equation 3 alone until the very end, and then I just do a left side, right side check. Minus 3 times t, which is negative 9 over 4. And again, you might want to just use your calculator for this. And this is 1 plus 14 over 8, sorry, which works out to 11 over 4. And this is 4 plus 27 over 4, which works out to 43 over 4. Now we interpret our solution. We got a solution for 1 and 2, but it didn't match with 3. So I say left side's not equal to the right side. Therefore, lines are skew, and there is no solution. Okay, that's what that one looks like. And finally, this is actually the easy one. There is a check that you can do if you take the normal and compare it to the direction vector, and you can dot them, and I'll let you try to remember what that means, what if you get a particular result, but that is something that you can try. But otherwise, solving these is actually pretty simple. And if I take the line and I turn it into parametric form, which normally we don't bother writing this out, but I am actually going to. So it's negative 1 plus 0t, so I'll just leave that. 2 minus 4t, and z equals 0 plus 5t, so just 5t. And I take those parametric equations and I just sub them in for x, y, and z in the plane. So 3 times x, which is negative 1, minus 4 times 2 minus 4t plus z, which is 5t, equals 10. Okay, so negative 3 minus 8 plus 16t plus 5t equals 10. And this looks like 21t. And 10 plus 3 plus 8 is 21. 21, not 21t, 21. Which means t is 1. And there are 3 different options that you can get here, because there are 3 different possibilities that a line and a plane will interact in 3 space. They're either parallel and distinct. They're either parallel and the line is in the plane. We don't call that coincident, by the way, because coincident means the same, and they're definitely not the same. One's a line and one's a plane. or the line passes through the plane and they intersect at a point. And it's all based on what you get here. And I'll remind you, if you get 0, t equals 0, then the line is in plane and you have infinite solutions. If you get 0, t equals some non-zero constant, k, where k is not equal to 0, then they're parallel and distinct. Okay, and if you get this, t equal, like not 0t, but t equals some k, then it passes through and you have a solution. And our solution occurs when t is 0 in, or sorry, when t is 1 in this case, because that's what we got. And so I sub t is 1 into this, and so my x is -1. My y is 2 minus 4 times -1, which is 2 plus 4, which is sorry, where did the -1 come from? 1. So it's 2 minus 4, which is -2. And z is 5 times 1, which is 5. Therefore, the line and plane intersect at a point. One solution, and the solution is a point, so -1, -2, 5. And that's your 3-part statement for that. So of course the other thing we did in this unit was 3 planes, but we spent a lot of time on it and we did that recently, so I will leave that to you. And that's just a quick little review of something. All of that we've done fairly recently, so hopefully it's fresh, but that might help jog your memory about some of those finer details.